It's pretty amazing when you think about it. Nature, over millions of years, has already figured out elegant solutions to some of the most complex problems imaginable. So today, we're diving into a really cool idea where computer science literally borrows a page from the wild. Let's see what happens when we unleash a wolf pack on our toughest digital challenges. It sounds a little strange, right? What could a pack of wolves possibly teach a supercomputer? Well, the answer is a lot, actually. It turns out the coordinated way that gray wolves hunt together holds the secret to solving some really, really tough computational problems. And this whole idea brings us into the fascinating world of nature-inspired algorithms. It's a field where researchers look at systems in nature, like an ant colony finding the shortest path to food, or in our case, a wolf pack hunting, and they figure out how to translate that incredible built-in intelligence into computer code. Which brings us to gray wolf optimization, or GWO for short. Now, it's what's called a meta-heuristic algorithm. Don't let the fancy word throw you, just think of it as a smart rule of thumb, a flexible strategy for finding good enough answers when a perfect one is impossible to calculate. It was introduced back in 2014 by Sayed Ali Mirjalili, and it's a type of swarm intelligence, which is all about how the collective, simple actions of a group can lead to really intelligent results. So the main goal here is really simple, but it's also incredibly powerful. We're creating a digital hunt. In this computer world, the prey we're after isn't an animal. It's the best possible solution to whatever problem we're trying to solve. The algorithm itself becomes the hunt to track it down. All right, so to really get how this digital hunt works, we've got to meet the hunters. The GWO algorithm is built around the very real, very strict social hierarchy you'd find in a wolf pack. Every single wolf in our digital pack has a specific job to do. And these roles map directly to the pack's chain of command. The alpha wolf, that represents the absolute best solution we've found so far. The beta is the second best, and the delta is the third best. And everybody else? Well, they're the omega wolves. They represent all the other possible solutions, and their main job is to follow the lead of those top three. Now, this leadership structure is absolutely crucial because it helps the algorithm balance two really important things. The first is exploration, which means spreading out and searching a wide area for totally new solutions. The second is exploitation. That's when you've found a promising spot and you need to zero in and dig deeper. The alpha, beta, and delta wolves are the ones guiding this delicate dance. So, how does this digital pack actually track down its prey, that perfect solution? The whole thing, as complex as it sounds, really boils down to a surprisingly simple three-step hunt. So here are the three phases. First, encircling the prey, where the pack starts to surround the target. Second, hunting, where they tighten that circle based on what their leaders are telling them. And finally, attacking, where they all converge on the final answer. It's a strategy that logically moves from a broad search to a super precise conclusion. Okay, so first up is encircling. In this stage, the pack, all those omega wolves, start to move in and surround the general location of the prey. And how do they know where to go? Well, they're constantly updating their own positions based on where their three leaders, the alpha, beta, and delta, are located. They follow the best intel. Then we move into the hunting phase. This is where the search gets a lot more focused. The alpha, beta, and delta, since they represent the best solutions found so far, guide the movement of the entire pack. They're basically telling everyone else, hey, the good stuff is over here, getting them closer and closer to that optimal solution. And finally, the pack attacks. In the algorithm, this is the end game. It means all of the search agents start to converge, rapidly closing the distance to the best known solution. This final push is what systematically weeds out all the lesser options until only the best one is left standing. Okay, this wolf analogy is cool and all, but so what? Where's this actually useful? Let's jump out of the digital forest for a minute and see where this algorithm is being put to work in the real world. And the applications are incredibly diverse. You might be surprised, because GWO is so good at that exploration-exploitation balancing act, it's used for all sorts of things. From optimizing massive power grids, to helping machine learning models pick out the most important bits of data, to designing better buildings, and even figuring out how to best allocate resources in a hospital. Let's just zoom in on one of those for a second, because it's a big one. GWO is actually being used to help design more resilient electrical grids.
It helps engineers figure out the optimal way to place things like substations to minimize damage from, say, a hurricane or even a physical attack. It's balancing cost with security. I mean, that is a seriously powerful application.
But, we have to be real here. Like any tool, the Grey Wolf Optimizer isn't a silver bullet. It's got incredible strengths, for sure, but it's also important to understand its limits.
One of its biggest advantages, honestly, is its simplicity. If you compare it to other popular methods like genetic algorithms, GWO has way fewer parameters you need to sit there and fine-tune. This makes it a lot easier and faster to just get up and running on a whole range of problems.
But on the flip side, it does have a few weaknesses. For problems that are insanely complex with tons and tons of variables, it can sometimes be a bit slow to find the answer. Its performance can also depend on where the wolves randomly start their hunt. And it can sometimes get stuck on a good solution instead of finding the absolute best one, kind of like finding a tall hill and thinking it's the highest mountain.
The good news, though, is that researchers are already working on this. A really common solution is to create hybrid algorithms. You basically take the strengths of GWO and blend them with other techniques, like maybe a neural network, to overcome its weaknesses and give it a serious boost in speed and accuracy.
So, what's the final takeaway here? Well, despite those few limits, the verdict is pretty clear. Grey Wolf Optimization is a genuinely powerful, super flexible, and really important tool for anyone trying to solve complex problems. And its list of applications just keeps growing.
And that brings us full circle, right back to where we started. If we can learn this much from the social structure of a wolf pack, it really makes you wonder, doesn't it? What other incredible secrets are hidden out there in the natural world, just waiting for us to discover them so we can solve our next big challenge?